So reactions of benzene. So there's what they're going to get you to do is we'll learn a few that you have to know off by heart, but generally they'll give you one that you've not met before and you have to kind of work it out for yourself. So we'll do some practice at those where I'm just going to give you random things and you have to work it out for yourself. But the key ones that you need to know, the first one is nitration, which is a super duper important reaction. Of those reasons we'll look at this a bit later on. But nitration, overall reaction. So not worried about the mechanism is we take benzene. I'm going to carry on drawing benzene as my little hexagon with a circle in the middle because it's pretty.
Why is the circle there?
The circle is delocalized electron.
Oh, I see.
Yeah.
That makes sense.
What you will find is after we've gone through this topic, what you find is every hexagon you draw, you automatically put a circle in it. You have to stop yourself putting a circle in. And I use nitric acid, HNO3. And my catalyst, which I'm going to put over my arrow, is concentrated sulfuric acid. So in this reaction, I've got benzene, concentrated nitric acid, and concentrated sulfuric acid. It's not a nice thing to do. Benzene, which we didn't look at, benzene is, it used to be used very widely in labs as a good solvent. It actually was then found that benzene causes cancer. So 50 years or so ago, if you walked into a typical chemistry lab, you'd have, you know, pots of benzene just knocking around. And then they found that it actually causes cancer, so they've had to remove it. So we will never use benzene in the school, it's banned. And we make nitrobenzene. So they are going to get really, really fussy about where you draw your bonds. Your bond goes to your nitrogen. Must go to the nitrogen. Plus water. So that's the overall thing that's happening. Generally, we don't do this in school. Concentrated nitric acid, concentrated sulfuric acid, and benzene. Generally, a recipe for disaster.
Is it a really explosive reaction? Or like
Yeah, we'll look actually at what happens when we carry on. So, let's look at the mechanism. Now, the mechanism, this is one of the more involved mechanisms that we'll look at. So, that's the overall. And this now is a mechanism. So let's try and work this out. What do curly arrows show? The movement
of electron pairs. Oh yeah.
Fabulous. The first thing I have to do is I have to make my electrophile. So the first step is to generate the electrophile. Generate electrophile. So this doesn't involve benzene at all. It involves my sulfuric acid and my nitric acid. If I'm making an electrophile, what charge is an electrophile going to have? Plus, yeah. If you go back to what we just done, what have I added to benzene? I've added, yeah, I started with nitric acid. What group have I added to benzene? It was benzene with NO2. So I need to add that. So that's my electrophile. So that's my electrophile, NO2 plus.
This might be a really stupid question, but the H2SO4 is a catalyst, right?
Yeah, that's right.
Okay.
We're going to regenerate it, yeah.
Okay.
I'm excited. So that makes plus HSO4 minus plus H2O. You've got to learn that equation. So how can this react with benzene? So I've generated my electrophile, I'm now going to react it with benzene. So here's little benzene, little circle. In comes my NO2 plus. So down here, NO2 plus. So the first step, my electrons come out of my ring and attack the nitrogen of that. So electrons, so they've made a new bond. That means I have got unhappy benzene. I've disrupted my delocalized electrons. So we put a little sad face on benzene. Oh, sad. And he's sad because on that carbon I've got a hydrogen and I've also got my NO2 group. And he's got a plus charge on him. So the ring must be broken where the bonds are here. So how can he be happy again?
He needs to get rid of H.
He does indeed. So those electrons need to go back into the ring. And they give me nitrobenzene plus H plus. So it's quite a simple reaction mechanism, really. 3 steps.
Does that H plus go to the H2SO4?
Whoa.
Only the
Yeah.
H2SO4.
Yeah, cool. And the final step is I need to regenerate my catalyst, which is H plus from there, plus HSO4 minus from there, gives me H2SO4. So I regenerated my catalyst. Regeneration of catalyst. Brilliant. That's all there is to it, really.